Hello everyone, and welcome to today's webcast, How to Improve Threat Detection and Hunting in the AWS Cloud Using the MITRE ATT&CK Matrix, sponsored by AWS Marketplace. My name is Carol Ott with the SANS Institute, and I will be moderating today's webcast. Today's featured speakers are Dave Shackelford, SANS Analyst, and Ross Warren, Specialist Solution Architect at AWS. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface. We will be answering them during the Q&A session at the end of the presentation. And with that, I'd like to turn the webcast over to Dave.
Rockin'. Thanks, Carol, and thanks so much to everybody for joining us today. I'm really excited to be joined by Ross and the team at AWS to bring this to you guys and talk about what I believe is sort of emerging in the industry, and maybe in more than one industry, because we're talking cloud and security and sort of the convergence of the two, in terms of like an attack model that we can all sort of gravitate towards and start making use of in developing our security programs and playbooks, and of course things like our threat detection scenarios, because let's face it, things do change in the cloud. We're dealing with software-defined infrastructure. We're dealing with lots of new sort of pieces and moving parts. And necessarily we'll have to adapt our security programs accordingly to facilitate better and improved detection and response capabilities there. So we've got a big, very packed agenda for you guys today. Lots of exciting stuff to talk about here. And so I'm going to kick it off with a bit of an introduction, just, hey, what the heck are we talking about in the first place? And then we're going to move quickly into the spectrum of not only the ATT&CK Cloud Matrix, but also some specifics in the realm of cloud that tie right into that. So without any further ado, let's get rocking on. Off we go. So kicking into this, one of the things that I found, and certainly for those of you that have been in the industry for any length of time, if you've been a security professional for a while, certainly if you've been on the defensive side, if you're more focused on incident response or forensics or those kinds of types of job roles, then this should probably be old hat to you. But if this is not necessarily where you've been, or maybe if you're coming more from cloud infrastructure or cloud operations, and you're simply curious about what's going on in the realm of security, for the last couple of years, this has been a hot topic of discussion, this notion of moving away from sort of classic, sort of simple, maybe, so sometimes simple, indicators of compromise towards a newer model and a little bit more robust model of attacker, sort of recognizance, which is what we call TTPs, or tactics, techniques, and procedures. And if you really get into some deeper discussions with the forensics folks of the world, trust me, they've got a lot of things to say in terms of what these differences are and why it's a smart move for all of us to sort of be heading in that direction. But let me give you my take on this as it pertains to, really the nature of today's attackers and attacks. Number one, this is not to say that indicators of compromise aren't useful anymore. And what I mean by indicators of compromise are usually sort of finite, distinct, and fairly singular things that an attacker might leave behind as an indicator of what it is they're doing. So this could be very simple stuff. It might be, a file with a particular hash value. This could be an IP address that's detected, saying, oh, well, obviously that source address, we know that's bad. This might be a username that is left behind for some sort of malicious user. The list goes on and on. But it's always some sort of very specific, kind of almost signature-oriented indicator that tells us, hey, something's going on in here and we need to go and follow up on it. Those have merit. It's not to say that they're completely useless today, not at all. But here's the problem we run into with this concept of static indicators of compromise. They're easily modified by the attackers. And in fact, there's been some great work done out there with things like the pyramid of pain and, really all these, kind of crazy ideas of how the attackers are adapting to us simultaneously as we're trying to get in front of the problems of security and hopefully prevent them from getting in, or at least detect and respond more rapidly. And if you look at these static indicators, again, things like source IP addresses or file hashes, again, the file looks like it did yesterday, thus the hash is the same. They can change those things so quickly. They can change their malware, they can change their files, they can change many of those sort of signatures, which makes it an impossible race to win. There's no way we're ever going to keep up with that. So what we found is that a better strategy for performing, not only threat hunting, but of course, just standard kind of classic detection and response activities is to focus instead on TTPs, which are much more difficult for the attacker to, fully modify or change. In other words, what's the pattern of the attack? What are the tactics that are being used? What are the specific techniques going from system A to B in terms of lateral movement or what have you? Those aren't necessarily as easy to change. And so there's been, again, some, great work out there in the industry. And cloud, of course, given that it's growing so rapidly, it's right there too. We've definitely got to take that same mindset and approach into cloud with us as well. And so what we want to focus on is, number one, how do we do that, right? What are the pieces and parts we need to be gathering and collecting and working with to effectively move away from, say things like static indicators and start coalescing TTPs instead. The good news is we've got so many great things to make use of in the industry that we can really do this very effectively. It's just a matter of knowing what those are and then, of course, putting in the work to accomplish that. So to improve our sort of security monitoring and response capabilities, obviously we should be performing more proactive threat hunting. Now, look, I know that's a lofty statement. It's very easy for someone to just go, well, hey, guys, you should just carve out more time in your lives and go do threat hunting. Yeah, I get it. But here's the thing. We can do it a lot more automated now. So there's so many cool ways we can automate things in the cloud because it's programmable infrastructure that it's not a huge lift operationally for organizations to just step in and be able to start performing those types of activities. So proactive threat hunting, yeah, we know we should be doing it, but we should be doing it. We need to be able to rapidly investigate. We need to be able to rapidly assess workloads and things like identity state and attributes. We need to align different cloud events to pull out those TTPs and detect them rapidly. And of course, what that means is, say, multiple indicators simultaneously that converge into a TTP. How do I pick that up? How do I look for and find that rapidly in my cloud environment? And then, of course, today, over the past several years, we've seen this sort of gradual evolution and maturation of security orchestration and automation tools and platforms too, which have now made their way into the realm of cloud as well, tying into things like programmatic interfaces, APIs, bringing third-party tools together in the cloud. So, hey, that's great if we have specific endpoint products or other things we want to start tying in. There's just so many ways that we can start to accomplish these goals that it's a pretty exciting time to be thinking about these problems and challenges and addressing them head on. So let's jump right in and give a shout out to the folks at MITRE. And Jen Burns and her team over there, I've chatted with her and talked about this, and it's a rapidly evolving project. So here's the thing, and of course any of you guys that are in the realm of cloud, nothing stands still for long in this world. And the ATTCK Matrix is right there as well. They're just a super smart, awesome group that is really working actively in the industry to try to help tackle this and provide sort of community knowledge that we can use to help identify attack patterns and, of course, specific attack patterns that tie into the realm of cloud computing. So what ATTCK really has always been focused on is things like adversary behaviors. So that's, I think, really one of the goals that the ATTCK team set out to really accomplish right at the beginning was, hey, let's get away from, like these really finite indicators and more specifically tie into, things like the TTPs. So adversary behaviors have always been on their list. Things like life cycle models for attacks, because let's face it, the attackers have changed their life cycle models definitively over the past 10 years or so. This is not a brand new transition we're seeing. They don't tend to just, come in, perform a smash and grab and get out. They tend to persist. So once someone gains access into your environment, they're unlikely to let go. They're probably going to look to deeply embed, hang out, pursue new targets, try to gain access to new forms of data and data types, and then ultimately compromise your environment much more thoroughly, but over a longer period of time. And that is a real-world attack scenario. That's exactly what we've been seeing consistently, especially with the more advanced adversaries of the world. Now, to finalize that, I think we've really been seeking somewhat of a sort of common attack taxonomy and to have some common nomenclature. And there's been a lot of efforts around this over the years. I think, ultimately the first time I remember some efforts starting up in this vein, it was around things like the kill chain and some of those different types of models. And those are all really interesting and worthwhile to go just dig into. But based on what I've seen working with a lot of different organizations and teams, certainly talking to my students in my classes at SANS, I think attack is really emerging as sort of the industry standard attack taxonomy and nomenclature mechanism that we can all make use of in things like, again, threat hunting, certainly threat modeling, and just building out playbooks and use cases that are effective. So it's again, there are lots of models out there, and of course, we know what that means. You're going to get opinions all the way around. But I've been genuinely impressed at, number one, just the breadth of information that's present within ATT&CK and ATT&CK Cloud, but also just the velocity at which they're updating this. They're really working hard to not only address, the nature of the fast-moving nature of cloud, but also how the attackers are making use of cloud and are attacking it in the first place. So this is what we're seeing as far as the MITRE ATT&CK Cloud Matrix. By the way, this is not hard to go access. It's all freely available on the MITRE site. So, I've posted the source link there, but, you're one Google search away from finding this stuff very, very quickly. And the cool thing is there's some really sort of unique and distinct cloud service elements that they're bringing into this. So let's face it, while there's some uniformity across the spectrum of things like infrastructure as a service, so you could say, well, okay, AWS is an infrastructure as a service provider. It's the largest, provider out there maybe. We can take that same knowledge from AWS wherever we need to. There's always some unique tweaks and twists, and they're really trying to address that. They're also doing some of that for the world of SaaS and SaaS applications too. So I encourage you, if you haven't just gone out and checked out the work they've done, go check it out. I mean, it's really worthwhile to spend some time there. But what I want to do for, the next couple of minutes is go through some of these distinct sort of categories within the Cloud Matrix and talk to those and give you guys some thoughts and examples around them. So again, this is just sort of the starting point. There's just so much that can happen within the context of any of these that I think it makes sense to talk through those. So we'll start off, again, just looking at the basics. The first stage, of course, is initial access. And this is when somebody finds their way into your cloud account. So, for whatever reason or however it's been accomplished, we've seen this movie before. I would say this is probably the piece that many are already relatively comfortable with, specifically around things like application exploits. So, hey, you've got something that's public-facing. As I always tell my students, I'm like, look, bad code is bad code. It doesn't matter whether you're running this in-house or in the cloud. It's still going to be bad code. So if you've got an application that's public-facing and it's just screaming for SQL injection, well, you know what's going to happen. So that's, of course, going to be one potential mechanism by which they gain access. The same could be said for trusted relationships. So if you've got some integrated components or maybe even sort of endpoints or systems, or if you've got some hybrid connectivity, well, that's always potentially a weak spot. So that could easily be a means of access. And then naturally just discovering accounts and exploiting them. And I think we all know the story around account access and identity and access management, not just for cloud, but for anything. It's the Achilles heel of all the computing that we do. We've always struggled with this. We continue to struggle with it. And if somebody hasn't properly secured their account and there's a means of access coming through the use of that account once compromised, that's going to consist of that initial access. So I think everybody sort of gets this. Hey, this might be the first, sort of touching point that the attacker finds to make their way in. Now, beyond that is where we start really stepping into the true attack paths. And so as I mentioned just a moment ago, once initial access has been gained, a lot of times attackers, right out of the gate, look for a means of establishing persistence. So I want to make sure that if, hey, this account gets cut off, or that application gets patched, I can still get back in. So I want to make sure I have a way back in once something happens. And so this is just, sort of a fail-safe, if you will, that tends to be that initial early stage sort of focus for the attackers. And this could be just creating a new account. We've seen this a number of times before, where depending on the level of privilege that the attacker achieves, that's the first thing they do is they go try to create a new account themselves, or potentially manipulate an account that grants later access by changing permissions or privileges or something. Implanting new container images. Given that we've seen a rapid rise in the use of platform as a service, people are spinning up containers and orchestrated container infrastructure that's a great way to sort of sneak in if you're not, paying close attention to things like your container repos and what's in them and what state they're in. Creating redundant access with different network controls or identity controls. So, again, just finding a new network path or perhaps establishing a new role assignment or privilege assignment, and then just continuing to leverage existing accounts too. I mean, obviously, if you have an account and it doesn't change, then you can continue to use that. But I tend to find the first few a bit more prevalent, especially with the more savvy attackers, because they don't want to take the chance that that valid account that they found goes away in some fashion. So these are just examples of persistence within cloud environments that we've consistently seen. Privilege escalation goes hand in hand with that. So particularly when they gain access as a less privileged attacker, we're going to find really unique ways to go about seeking better privileges and more privileged access. And so, usually you'll find that we're trying to use the valid accounts we have and then gain access to other parts of an account or different user or group entities, or manipulating the identity role assignment to then use these accounts. And truthfully, especially in big organizations, this is an ongoing battle that we're fighting just because identity is woven into the fabric of cloud implementations, and it's a configuration issue at heart, right? It's something that we've really kind of worked hard to get better at, but still, especially in really big organizations with lots of users and groups and roles and service accounts, you might miss one, right? You might miss some privilege allocation that's just a bit too privileged and could be leveraged by an attacker if they can get to it. So privilege escalation is a really common tactic that often goes hand in hand, like I said, with not only persistence, but this next phase of trying to avoid defenses. Because it turns out, once we discover some of the defenses that are in place, they usually require privileges to modify or potentially avoid in one way or the other. So finding redundant access, I mean, truthfully, we'll see cases where, people are setting up accounts or setting up, some sort of, let's say, container image or something in, let's say, a different region than you're normally operating in. They'll find some aspect of your account that you're not paying as close attention to as you should, and they'll try to, sort of siege something over there, and that's a means of evading, the defenses. Reverting a cloud instance to a previous state. So you find like a previous image that you can take advantage of, and you revert things, and maybe that goes unnoticed. Like I said, continuing to leverage the existing accounts. That's a persistent theme here. So if you've got account access, and certainly account access with the appropriate level of privileges in place, that's a surefire means of just continuing your attack. Credential access, it's the number one thing everyone seeks. So if I can get creds, and this is coming from someone that's been a pen tester for many years, I'm always going to go after credentials. So if I'm an attacker, or I'm obviously simulating an attack as a pen tester, if I gain in that initial foothold and find a way of keeping myself there, I am going to actively seek out some types of credentials in the environment, because that's how I'm going to further my attack at that point. I'm going to look for, some sort of manipulation capability. So how can I change the account or modify it to better suit what I'm trying to accomplish? Looking for identity roles using the metadata API. So coming in and saying, hey, there's an instance profile assigned to this workload that I've compromised. Can I manipulate that? Can I query it and make use of it to go then potentially gain access to other parts of the environment? And again, the way that cloud is built, identity is kind of the glue that holds everything together in many ways. That is a very common tactic that we're consistently seeing. And then, let's face it, I mean, this is a persistent issue as well, finding embedded credentials in files. And I know much has been said about this. I mean, you can go all the way back to 2013, 14 with people accidentally publishing their API keys in, GitHub repos, and, people that have Docker, container sort of configuration files, right? Our Docker files have some sort of keys or credentials in them, or just any number of different ways. But this is an old problem. It's just a new place that it's happening. And so we tend to see, especially with fast-moving, very dynamic environments, that sometimes these things get embedded deeply. And, you just have to go with it. It's what it is, and you should be seeking out and looking for these things in your environment actively as well. So this is common, again, looking for credentials. Then once they have credentials or a certain level of access, I mean, I'll summarize this one quickly. It's anything they're going to want to go look for that gives them more detail, more information, more data, anything about the environment itself. So this could be system discovery, it could be network service discovery, It could be network shares where different content is being exposed or hosted. It's new cloud services that are enabled and running in the environment. It's even things like service dashboards that you might be able to take advantage of and gain information about how the environment is operating. So let's say, for example, I get into the environment and realize through some programmatic means I can go access things like CloudWatch and AWS. I can dig in and find out an incredible amount of detail about what's happening in that environment depending on what's been enabled there. So this is always the sort of ultimate goal that leads towards the penultimate stages of the attacks, is getting enough access to really, sort of hang out, and then discovery. What's in here? What can I go find? What can I look for? Some of it might be fruitless, so you're going to go dig around all over the place and find that, yeah, that service isn't running, or this is not a particularly interesting network service or asset. Then you'll, of course, find some things that are. So also tend to be, again, sort of useful as an attacker progresses. Then you start collecting data. The number one thing that people are after is, of course, data. So this depends on what you're running in the environment, whether it's in things like RDS or S3 or other sort of big data warehouses. It could be local system data. It could be application-specific data. But any sort of data access is almost always at least one of the goals of an attack. And so naturally, what we've seen is a shift as defenders towards really carefully scrutinizing and monitoring access into our data sources and storage locations in the cloud, because this is where they're headed. And once they've done that collection, ultimately they're probably going to try to get this out. So they're going to transfer data out to another account or some other location. And then ultimately, this final phase is impact, meaning, well, what's the ultimate goal of the attack? Data access might be it, and data exfiltration might be the extension of that. But it's the impact to the organization and the benefit to the attacker, which could come in the form of just stealing and selling data, of course, or even things like resource hijacking. And at this point, if they've gained access into your account and they're doing evil, horrible, terrible things there, then they've hijacked resources in the first place. So, of course, this is definitely a generalization of what the folks at MITRE have put together, and they've got a lot more great detail that they can go into on any one of these different categorical phases of an attack pattern. But it's nice to see that shift towards cloud, that specificity that goes along with cloud assets, cloud resources, cloud workloads, cloud services, and the specific lingo and language that we're having to adapt to as we start building out more software-defined infrastructure. Now, turning to us as the defense side, what in the world are we going to do about this? I mean, it's great to just sit and go, well, yep, terrible, attackers are attacking, that's not great. Well, we know this. So what are we going to do? We've got to start with logging and event analysis, meaning we've got to get logs from everything we can possibly get them from within our cloud environments. And the second thing that we need to do is track those events and monitor for them carefully, which sounds suspiciously like the kinds of things we've been trying to do in our own environments for a long time. The difference here naturally being that we're going to use cloud-based environment systems, assets, services, and tools to accomplish a lot of this. So you look at something like AWS CloudTrail, and I've extolled the virtues of AWS CloudTrail for many years, but it is quite literally a master switch of everything in your software-defined data center. So you know every API call that's being made, and I can generate that event data and then feed it into any other number of event correlation and monitoring tools that I need to. On the network side, we have VPC flow logs. So you can enable those and obviously send them to a central collector as well, but this shows you those definitive patterns of network access and communications that you'll need to build out baselines and start monitoring for anomalous scenarios or anomalous conditions in your cloud environments. So both of those, number one, you just got to turn them on and start collecting them. But then, of course, you've got to start thinking about, well, what else can I use in the environment to potentially trigger an alarm on something I want to know about? So I always start with billing alarms. Truthfully, it is surprising to me sometimes when I work with clients that haven't really given much thought to this and haven't truthfully, sort of settled in and put these together, because billing alarms are one of your first stage indicators that something is wrong. It might not be something malicious that's wrong. It might be a mistake that was made in a provisioning scenario where you've over-provisioned a resource accidentally or in some way, and you simply have to go correct that mistake and move on. But, the bill tells the story of that. Sure enough, though, if an attacker comes in and says, well, what a great place to set up shop and do some crypto mining, let's do it, billing alarms are going to tell you that, and tools like AWS budgets provide for very granular types of billing alarm thresholds and monitoring capabilities. IAM activity in the cloud is one of your top focal areas. So any sort of login, truthfully, when you move to a more dynamic and programmatic means of controlling your environment, you really shouldn't see a lot of just active logins from Dave, right? Hey, what is Dave logging in and doing? No, most of it should be coming from your pipelines and deployment workflow engines and components, or system services and things that are running internally. And you need to make sure you're sort of logging those and tracking them. So any sort of IAM activity is interesting, but logins in particular are of interest. And then your overall cloud environment logs, which I'm going to point out a few examples of here in just a minute. Every single API event tells a story. It might be a really boring story depending on the event, but some of them far less boring. And again, I'll give you guys some examples of those as we get into this. You've got some new tools. So built right into the fabric, you have some service capabilities that are immensely useful in helping to further your detection and response scenarios. Analytics like GuardDuty running in the background. GuardDuty is pulling all this data. It's looking at CloudTrail. It's looking at VPC flow logs. It's pulling things like Amazon DNS lookups. There's additional threat intel that's coming in from Amazon partners, and it's all being converged and coalesced into something meaningful that's running in the background all the time and telling you, hey, these 4 things occurred, and that's a behavioral pattern that's indicative of some sort of crypto miner, or this is a botnet command and control example that we've seen in the past. So not turning on things like GuardDuty, it's craziness. You should absolutely be enabling that, because it's yet another powerful tool in your arsenal that you don't have to really spend a lot of time sort of giving care and feeding to. VPC traffic mirroring is a way to actually acquire network packet captures. So if you want to feed things into other types of intrusion detection systems or other sort of network forensics engines, this is how you do it. And being able to tap into not only the traffic running across your VPCs, but being able to filter what you don't want right out of it and only collect the sort of data that's most interesting to you, that's fantastic. So if you want to use some of those types of traditional tooling, you most certainly can. Detective, a newer service, but one that's gaining a lot of traction, and it really is sort of a mass-scale aggregation of logs and event data, and it gives you even deeper analysis to look for behavior anomalies and other events. And the cool thing here is that this can act as an engine for investigation. So it's not just sort of that back-end monitoring that something like GuardDuty would provide. It's that to some degree, but it's also a place that you can go perform threat hunting directly, because it's tied straight to the event data that you're interested in. And so you can go in and build queries and actually have this as part of your investigative analysis dashboard. You've also got SecurityHub, which is great for, I think, 2 specific things categorically. Number one, going and sort of assessing the environment and looking for, just best practices that are defined by CIS and AWS, but also for linking in third-party tooling. So that's another great scenario that you guys can take advantage of. So to sort of move into the next discussion area, integrating things like automation and security orchestration, there's so many different use cases and models that you guys can come up with, and it's really a great place to get creative. These are just a couple things that I've seen people consistently trying to do right out of the gate. So, identification and correlation of alerts, that's a big one. But also tuning down false positives, because you're going to find some cases where it's like, oh, no, that's our specific weird app. Yeah, it's noisy, but we know what it is, right? So while it looks like, oh my gosh, there's some sort of identity problem here, it may not be. It might just be your own infrastructure, and being able to identify and suppress that automatically or in a more automated way is great. Performing investigations and threat hunting, of course, opening tickets and alerting an analyst that they now own that ticket and need to follow up. And of course, doing things like producing reports and metrics. Those are a lot of times the starting points. These are some other examples that I've actually seen people implement, things like automated DNS lookups for new domains, searches for specific indicators or TTP elements, and being able to do that automatically. Even things like automated forensic imaging. You can kick the entire forensic acquisition process off in an automated way for a suspect event. So grab memory, grab disk, copy that to an S3 bucket, and use that as the impetus for follow-up investigations. You can even block obvious command and control channels. So if we see something that's very obviously a C2 channel in the environment, you could block that or quarantine that temporarily and follow up. All of this, great examples of where automation can make your life easier. Now, this goes into sort of a specific TTP detection and analysis and response case study. If you're just kind of following through the various attack phases, looking at those TTP elements, right, like discovering valid accounts, creating new accounts and persistence, establishing a presence somewhere that might not be detected, querying an identity role, using the metadata API, especially in an unusual way, finding credentials, looking for system discovery, network connection discovery, all the things we just talked about. If you take that one step further and sort of look at an example, I said, okay, well, what would it look like, and what would you do about it? So if I'm looking for somebody discovering a valid account, we would have a CloudTrail event of an account login or potentially somebody coming through the management console. If you're looking for the creation of new accounts, again, a CloudTrail event for a new IAM account created is pretty crystal clear in terms of what it represents. In terms of defense evasion, establishing a presence, if you see anything happening in a region that you don't use, that's a first tier sort of priority event to follow up on. Looking at CloudTrail events in GuardDuty or Detective, again, I'm seeing that account use in different ways than what I should be expecting. Looking at credential access, absolutely looking at the metadata service queries on the back end in unusual ways. If you've got metadata service queries going on naturally as part of your infrastructure, there's a pattern that develops. If an attacker metasploits their way to glory in one of your workloads, that's not a normal pattern when they start digging around and manually performing curl queries against your metadata service. Looking for credentials and files, again, it would probably be things like account logins or account queries. Moving into discovery, well, GuardDuty events around network or service scanning, and by the way, those get picked up. Like obvious scans or evidence of network scanning is something that immediately shows up. Looking for local syslog or Windows event logs from workloads. If somebody's trying to dig into those, you can send those off to places like CloudWatch Logs or a SIM. Obviously, GuardDuty can start looking at behavioral connections from flow logs and start telling you that too. Account access to S3 if somebody's trying to get access to storage in the collection phase, or pull data from local systems. Again, that could be coming from local system logs. Exfiltration, absolutely something flow logs are going to show you, especially in large patterns or large scale patterns that are unusual or haven't been seen before. So you can start to really see where all of these components sort of coalesce and converge, and it's simply a matter of enabling them, learning them, and starting to build out playbooks and use cases. So where do you go from here? I'd say, hey, the next step for anybody that's really looking to up their game in cloud detection, go dig into the MITRE ATT&CK Matrix for cloud. I think that's sort of the first thing if you're not comfortable with it or sort of familiar with it already. I'd say for each of these TTP techniques or procedures, look at the events that would constitute that. Go into CloudTrail, become familiar with those API nomenclature specifics, then look at those events in conjunction with other events, and that's got to be contextual based on your environment and what you're running. And then start making use of things like Lambda, other types of serverless infrastructure to help create those automation patterns, particularly in league with CloudWatch or other types of SOAR engines. And then once the SOC team starts getting comfortable with these things, again, start building out test patterns. And it's a perfect case for things like purple teaming scenarios. There's just so many ways those teams can collaboratively work together to not only build out attack cases, but learn the detection strategies that go along with those. So the next steps, there's plenty, but you've got all the tools at your fingertips to actually do this. So with that, I'm going to hand things over to Ross. Take it away.
Hey, Dave. Thanks very much. My name is Ross Warren, as Dave already said, and I work at AWS as a senior solution architect, and I specialize in security, threat detection, and incident response. I'm going to build on some of the great things Dave said. There's going to be a little bit of overlap, but that should tell you these things are important. So if you hear me say something again, like GuardDuty and SecurityHub, write it down, dive deeper into what does actually mean in your environment. We're going to discuss some other tools also that's going to help your threat detection and hunting programs, no matter what stage you're at. As Dave said, some of you may be familiar with a lot of these techniques, some of you may be just brand new folks here. So we're going to take the time and walk through those things. And if you've been in any of my workshops throughout last year, not too many this year, we talk about these attack phases. I may not have labeled them exactly the MITRE ATT&CK Matrix, but if you kind of wink at them or squint at them, you'll see that they're pretty much the same. And we talk about how GuardDuty covers a bunch of those different phases. And then near the end, we're going to discuss a few customer success stories, really to show you real-world examples, through that customer lens. Let's start with a couple tools. This slide looks kind of busy, but all of these work on or are related to security in your AWS environment. Today, I'm really just going to talk about GuardDuty, SecurityHub, and Detective. As Dave has mentioned, GuardDuty is a managed threat detection service that uses machine learning so that you can monitor your AWS environment with just a few clicks. It is really, really easy to enable, to turn on. And as Dave said, if you've got workloads in AWS, you should have GuardDuty enabled. After this, go in your account, turn on GuardDuty if it's not on already. And then SecurityHub. SecurityHub is giving you that comprehensive view of your security alerts and your compliance across your AWS accounts. It really is that single place that aggregates, organizes, and prioritizes your security findings. You're getting findings from multiple different services like GuardDuty, like Macy, like Inspector, as well as those third-party sellers from the AWS Marketplace that we'll talk more about in a minute. And also does that continuous monitoring for compliance status, based on best practices, based on industry standards, such as the AWS Foundation's benchmark or PCI. And then Detective. We'll back up one for Detective. Brand new service, as Dave says, really getting a lot more traction. And Detective makes it easy to investigate, analyze, and identify the root cause of potential security issues or suspicious activities, right? It is automatically taking log data from multiple different sources, multiple different resources, and applying statistical analysis, graph theory, and building up a linked set of data that is really enabling you as the SOC analyst to conduct faster, more efficient security investigations. Now, what's really cool about all three of these services is they are tightly integrated. If I'm in GuardDuty and I see a finding that I want to dive deeper into, very, very easy, right-click in, I can pivot into Detective so I can start doing those deeper dive investigations. So I start forming hypotheses to actually do my hunts. And same thing with SecurityHub. If I'm in SecurityHub and I want to pivot from a finding into Detective, it's very, very easy integration. We'll dive a little bit deeper into each one of these services. As I said, some of you are new here. Some of you, this may be old hat. If you're trying to perform threat detection, if you're trying to understand and separate malicious behavior or unauthorized behavior from what is normal, GuardDuty is where you should go. It does a few things really, really well. It identifies known bad IP addresses in your logs and helps determine what is normal in your accounts and workloads. It builds a baseline of network traffic. It builds a baseline of API activity for your accounts, and then determines and alerts on any spikes in that baseline, such as unusual console logins or spikes in network traffic. And I'll hit home again. As I said, GuardDuty can be enabled with no software, no hardware, no architectural impacts to your workloads. Go enable it. Go click that Enable GuardDuty button today. GuardDuty is getting its data, its logs from CloudTrail, from VPC Flow and DNS, and it's monitoring billions and billions of events each day. Recently, GuardDuty also added coverage to monitor for highly suspicious data access and anomaly detection for your data residing in S3 buckets. So really, really cool new feature. You should go check it out if you're concerned about what's going on inside your S3 buckets. So how does it actually detect bad IP addresses? It's combining threat intelligence from AWS Security and from third-party intelligence partners. It's taking that. It's doing anomaly detection and machine learning to intelligently detect malicious or that unauthorized behavior. And then all my GuardDuty findings, they're dumped off into CloudWatch events. These alerts are actionable. Dave talked about doing things with Lambda and automating stuff with Lambda. It's really easy to aggregate those findings across multiple accounts and then push into an existing event management system or write your own Lambdas to actually do some of those automations. We'll talk a little bit more about that with SecurityHub. And the best part, this is all happening behind the scenes in your environment, so there is no footprint. Amazon Detective, right? SecurityHub and GuardDuty are really helpful in alerting when you have something wrong and pointing out where to go fix it, right? It's a point in time. Something's happening right now, Ross. But Detective really helps enable threat hunting by allowing you to dig a lot deeper, to ask questions of your data, analyze over time, and isolate the root cause and take some action on that. Detective is getting its logs from CloudTrail, VPC Flow, and bringing in GuardDuty findings. And I'm now able to focus on IP addresses, accounts, EC2 instances, and each one of those has a detailed panel about what is associated with those accounts, who instances have been launched with this account. And a brand new feature was just released. You now have the ability to drill down into the details of your VPC flow logs. There's a blog post coming out very soon about that, but it's enabled in all of your accounts if you already have Detective. Detective presents that unified view of user and resource interactions over time. You can scope the time, you can expand the time, and get really detailed information about what is going on. It really helps you get to the heart of the root cause. And as an example, I like to point out, you've got an unusual console login from API, from CloudTrail inside your GuardDuty findings. Great. I don't know where that's coming from. I don't know if that's actually normal, and I want to pivot and find out, is this normal for this user? Have they been doing this in the past, or is there some compromise happening here? So in Detective, you've now got all the details with these API calls and the trends for those API calls over time, and you actually have user login attempts located on a geolocation map so that I can see that, hey, this has been the normal activity for George, and now George is all of a sudden logging in from some other place that may be normal because you're moving business to that location, or maybe the creds have been stolen like Dave was talking about, and we've got something else going on in a different location. Now off into SecurityHub a little bit and some of the integrations that it can provide. You know, as Dave and I both have mentioned, SecurityHub allows quick access to those security alerts and compliance status across your accounts in one comprehensive view. There's a broad seller ecosystem with tons of integration, from everything from endpoint to security to firewalls to vulnerability scanners. You should check out the list of possible integrations for yourself inside the SecurityHub console. Because of this broad seller ecosystem, you can use SecurityHub to continuously aggregate and prioritize findings from AWS, like I talked about, GuardDuty, Inspector, Macy, and third-party security solutions such as Splunk, which is a great way to highlight emerging trends or issues. Many of you may be familiar with Splunk, and we're going to talk a little bit more about it, but it's a really great tie-in for SecurityHub if you've got workloads inside AWS. You know, Splunk can augment our picture, our security picture, with additional analysis that's outside of SecurityHub, has some remediation capabilities, and part of this integration is it's bidirectional. So not only am I aggregating all my AWS findings into SecurityHub and maybe sending them into Splunk because I've got Splunk and I've got an engineering time into that, but if you do some safe searches, if you do some findings inside Splunk, they can actually be sent back into SecurityHub and just enrich what I've got in that comprehensive view. And remember, I mentioned compliance status. So on SecurityHub's dashboard, you've got a score about how you're doing against security standards and displays. It's just right there on the main dashboard. These automated checks are happening all the time in the background against industry standards and AWS best practices. It's really a great place for you to go to look over time how things are happening. If there's a control inside a practice that you may or may not be relevant to your organization, you can actually disable it. So you can do a little bit of manipulation and configuration of those to what is necessarily for your organization. For those of you who have been using SecurityHub for a while, please go check it out. If you haven't, there's a couple new features. We've got 7 new automated security controls inside the foundational best practices, and there's actually 12 new controls set for the PCI standard. Another great workflow for SecurityHub and a little bit of automation or getting things done, as Dave was talking about, is custom actions. There's a couple great blog posts out there on custom actions in SecurityHub, but what you're really enabling is a response workflow via CloudWatch, because just like GuardDuty, SecurityHub sending everything to CloudWatch. And custom actions or operations include things like sending findings to chat, sending things to email, sending things to a ticketing system, kicking off a Lambda, waking up Ross at 3 a.m. because something has happened. It's a great way for one of your SOC analysts to select an alert that they want to do a manual thing on. And really, this is the art of the possible. What are you actually doing here? And your workflow really benefits from these defined actions. It's reducing that dwell time to investigate and remediate the findings, because I'm sending them off to somebody else. I'm sending them off to a different workflow to get things done. I mentioned Splunk a couple times already, so let's discuss how AWS users are using Splunk for threat detection and hunting. Splunk really provides end-to-end visibility across any data, source, type, volume, and or location. If you've ever used Splunk before, you know it's really easy to get pretty much any kind of data into Splunk and collect it and analyze it pretty much, as I said, from anywhere. By having this data at your fingertips, IT and security improves that investigation and workflow effectiveness. They get a better view of the entire infrastructure because you're bringing in the data is just so easy to bring in. There's risk detection. There's behavior analysis as well. That's going to help you inform that hypothesis creation. Right? Part of threat hunting is I have a hypothesis about what may be wrong in my environment. And so using all these tools, GuardDuty, SecurityHub, Detective, and Splunk, really you're helping form that creation and then helping to confirm or disprove your hypothesis. In threat hunting, it's okay to actually disprove your hypothesis and move on, and maybe you need to change your hypothesis and start another hunt. Whether you're managing an application, infrastructure, Splunk Cloud and Splunk Enterprise really help deliver operational intelligence for that real-time understanding of what's happening across your business. All right, let's translate some of what I've been talking about into a real-world scenario through a customer success story or two. At AWS, as you know, we love customer success stories. So the city of Los Angeles, to protect its digital infrastructure, they required awareness of its security posture and risk intelligence for all of its departments and stakeholders. And before deploying their solution with Splunk, the city had more than 40 agencies, and they all had disparate security measures. And so if you sit back, even in just your own environment, think about how, 40 times that, you can imagine how complicated the consolidation analysis of that data was before deploying this solution. The city sought a scalable SIEM solution to identify, prioritize, and mitigate risks, and really gaining visibility into suspicious activities. And so since deploying Splunk Cloud and Splunk Enterprise, the city has seen and established a citywide security operations center where they now have visibility everywhere. And you've got a little bit of a screenshot there of what's going on. Real-time threat intelligence. So with all that security data in one continuously updated database, they increased their ability to view both structured and unstructured data. Remember, that ability to get data into Splunk is pretty easily, and extract actionable security intelligence out of that. And they reduced operational costs, right? The security team now can focus on security events rather than deploying and maintaining infrastructure that they may have done previously, on-prem. With these new abilities, with this reduced time to detect and respond to incidents, The analysts are now conducting more searches, conducting more forensics investigations in a quicker, more efficient method, right? They're reducing that time to detect. They're having fun. They're finding things out in the network. Another customer success story, right? There's just lots of great solutions available in AWS Marketplace that can support threat detection in your hunting efforts. And one of those is Recorded Future. Recorded Future's threat intelligence solution offers a great add-in to any investigation. We talked a little bit about threat intelligence, but right, it's a combination of knowledge, data, and context that allows you to prevent or mitigate cyber attacks. So using Recorded Future, it's possible to uncover additional details about the adversary, the infrastructure of the adversary, the capabilities of the adversary, and who are the victims, right? In order to piece together a more cohesive picture of the threat and how that threat operates. Let's look at an example we've got on the screen there, right? St. Jude Medical, an Abbott company. As a leading global medical device manufacturer dedicated to transforming the treatment of some of the most expensive epidemic diseases, they needed to closely monitor the health of their cybersecurity landscape. Recorded Future helped St. Jude Medical detect those complex events and potential incidents that could have possibly been missed without the enrichment from threat intelligence. You know, they helped them reduce exploit kit traffic, and they had better detection of botnet traffic across a reduced set of sources. So St. Jude now combines real-time threat intelligence from Recorded Future with its Splunk SIM to more effectively fulfill the mission of their Cyber Threat Action Center. And they're now identifying, protecting against, and responding to more cybersecurity threats. And once again, you know, their analysts are now freed up to spend more time on malicious IOC investigations like Dave talked about. You know, honestly, that's the fun stuff. Diving deeper, doing threat hunts, figuring out if the bad guys are in my network or not. Lastly, let's talk about Grasshopper Bank. You know, one more customer success story. Grasshopper Bank, if you don't know, is the first digital-only cloud-native commercial bank to launch in the U.S. And it needed to secure its homegrown code as close to the code as possible, and they chose Contrast Security's Contrast Protect to provide that continuous visibility. After working with Contrast Security's Assess and Protect programs, Grasshopper Bank had deep visibility into their applications and their user behaviors, and they added this extra layer of security without investing in any expensive hardware, costly money, because everything was actually in the cloud, right? Security starts with your code. As Dave said, if you've got code running wild on the internet, you know what's going to happen. And so Grasshopper Bank really talked to Contrast Security and started to help protect, get visibility into what is going on there. Their improved security posture is welcome in the heavy regulated financial industry and appreciated by their security conscious customers. By deploying the Contrast Assess program, Grasshopper improved the threat detection at the application level and now takes advantage of virtual patching, which actually allows for quicker and easier updates to be pushed out to all their applications. And so starting to wrap this up as I'm watching the time, you know, we've been talking a lot about solutions, and I've hinted a couple times at the AWS Marketplace. If you don't know, the Marketplace is was built to help reduce that friction of deploying software into your AWS environment. If you're looking for a firewall, you're looking for endpoint protection, you're looking for vulnerability scanning, and you want to know the right way to deploy, check out the AWS Marketplace first. Even if you're on-prem or you're moving to the cloud or you're already in the cloud, you know, the seller you're thinking about may already have a presence, a CloudFormation tape, an AMI to actually deploy and make with you to help you get things started. One of the cool things with the Marketplace is you're able to actually enable software that's going to be bought in a more cloud-like way. And so what does that mean, Ross? If you're buying a firewall, you're typically buying for a license for a year maybe. But if you're working in an elastic environment like AWS, where you need to scale up and scale down based on demand, you need to have flexibility. And so the marketplace actually provides software that you can pay for by the hour. So you don't actually have to buy that license for the peak. So for example, you might be buying 2 annual licenses for your firewall, but when you scale up, you're really just paying for the hours that are used. There's a trade-off in costs, but in general, if you're working in this elastic environment like AWS, you should see savings. There's also very, very simplified deployment. A lot of the products are software as service, so you have nothing to deploy at all. Lastly and best, there's a team of solution architects that support AWS Marketplace and the products within the marketplace. They can help you ask the right questions of those sellers, get connected to sellers that maybe you want to talk to, do a proof of concept with, and help solve your problems. So how do you get started? In the marketplace, there's a few hundred security vendors. Each one of them has free trials. They have pay-as-you-go. You can actually bring your own license. So if you already have license paid for something that you're working on-prem, talk to your SA. Talk to the seller, and maybe you can bring that license onto AWS and deploy that in the cloud with you. So maybe you've already got Splunk on-prem, and you are starting to move Splunk into the cloud and want to move everything into the cloud. Talk to your Splunk partners. Talk to your SA and see if you can actually bring your own license into there. There's also seller private offers and partner private offers. You may have already negotiated a different pricing model, and that's not available, or you can't see it actually in the marketplace. That's great. Bring it, talk to us, and those unique transactions will show up in that one place on your consolidated AWS bill. As you can see on the right-hand side there, there's also multiple different deployment options. So CloudFormation templates, software as a service. These sellers are all going to provide you the easiest cloud-like way to get you to be using their products on AWS. And finally, sort of new, we're finally providing support for container services. A lot of customers are moving container services and still want to use their tools. And there's multiple different container service versions of many of these security tools. Wrapping up, it was great working with Dave today, and they talked a lot about tracking TTPs as a valuable effort for any mature security team. Using that MITRE ATT&CK Matrix for the cloud can help you build those chain TTPs in your AWS environment. Start helping you do those threat hunts. Start helping you build your hypothesis about what is going on. He mentioned right away, right? That landscape is changing regularly. It's emerging all the time. And security organizations should be diligent about monitoring for new attack paths and patterns they see in the wild. Remember, leverage AWS as a service that integrate with your AWS environment. We talked about GuardDuty. You heard us mention SecurityHub and Detective multiple times. Take a look at them and understand what's going on. You've got current tools that you use on-prem or in some workloads. You can bring your own license to leverage the benefits of the AWS Marketplace. New tools, you're starting to think about moving. Let's talk. Let's have a discussion about what is best for your environment, what is going to be best for your business cases, and see what we can actually use inside the cloud. Makes sense to pick vendors that know the AWS cloud intimately. So let's work together to actually do that. Splunk is one of those great examples of a vendor that is super tuned into the needs of the customers in AWS environment. I also talk about Recorded Future and Contrast Security, who are also well integrated into AWS. Last but not least, you can always ask your AWS SA how to best integrate tools or processes to improve your security posture. Thank you very much for your time today, and we are just about out of time, Carol.
Yes, unfortunately, we are out of time. Thank you so much to our speakers for your great presentations, and thanks to AWS Marketplace for sponsoring this webcast and the entire Cloud Security series. To our audience, we greatly appreciate your listening in. We look forward to seeing you on the next webinar in this Cloud Security series.